In this episode, Curiosity climbs up Vera Rubin Ridge, finds what some scientists believe to be fossils, and survives a global dust storm that permanently incapacitates another NASA rover. You may have noticed that Curiosity hasn't taken a drill sample for quite some time. This is because the last time the rover attempted this, in December of 2016, a key part of the drill stopped working. The rover arm was originally designed with two finger-like stabilizers within which the drill bit extends and retracts. A faulty motor stopped the drill extending past the stabilizers, and the team has been looking for a fix ever since. On Sol 1780, the team at NASA manages to get the drill out to its fullest. Extension 110 plans to bypass using the stabilizers altogether. This would be similar to freehand drilling, such as when people drill into the walls of their home. This new technique is named feed extended drilling, and NASA scientists will have to hack into the rover's other capabilities, such as pressure sensors on the rover's arm, to be able to do this successfully and safely. Curiosity is approaching Vera Rubin Ridge. The horizontal stratification of the rock, coupled with the crisscross white veins, are indicators of fluid flow through the rock. This ridge will make a great target. To test the new drilling method, the rover edges closer. The team at NASA decides to deploy Curiosity's dust removal tool on a nearby rock. First, the dust removal tool is inspected for damage. The wire bristles are spun at 10,000 revolutions per minute for a duration of around 60 seconds. When removing dust, the wire bristles seem to be holding up well, and the rover is ordered to proceed. The brushed area is around 2.5 inches, or 6 centimeters across. The purple tint signals the presence of hematite. The area is nicknamed Christmas Cove. When applying Curiosity's science camera filters, the presence of purple-toned hematite is undeniable, signaling the presence of water in the past. The white veins are believed to be calcium sulfate minerals, also caused by the flow of water. On Sol 1856, the rover reaches the top of Vera Rubin Ridge. The view from here is incredible. The slopes in the distance make up the northern wall of Gale Crater, and Curiosity's landing site is also visible. The rover is really starting to gain some elevation as it heads up Mount Sharp at the top of Vera Rubin Ridge. The rover comes across some strange stick-shaped features. They are about 5 to 10 millimeters long, or about the size of a grain of rice. Some scientists believe these could be ichnofossils, a record of biological activity in the past, but not direct fossilized remains of an animal or plant. They argue that nothing like this has ever been seen on Mars before. They are concentrated in this area and they resemble trace fossil burrows back here on Earth. What makes this even more compelling is that Vera Rubin Ridge could very well have been an ancient shoreline. The rover planning team gives Curiosity some more time to investigate with its ChemCam instrument, however, it fails to gather any usable data. NASA believes these features are simply fracture fills that are more resistant to erosion, which have broken up to create these small, dark sticks. What do you think? Leave your theories in the comments below. Curiosity comes across a staircase-like feature atop Vera Rubin Ridge. The layering of the rocks up here really interests the team at NASA. The rover turns its focus towards Mount Sharp. The area in the midground is believed to contain large amounts of clay. This map shows the journey thus far. The rover has made it over the Bagnall Dunes up onto Vera Rubin Ridge and is making good progress up the base of the mountain. Curiosity takes a selfie at its current location on Vera Rubin Ridge. The team at NASA wants to test the new drilling technique here on Sol 1956. The rover performs a partially successful drill using the new so-called freehand method at just 2 depth isn't enough to enable Curiosity to process the sample, but it's a step in the right direction. Before we go on, did you know that you could actually save money by switching to a Henson razor? Take a look at this graph. This is the cost of shaving using a typical cartridge razor over a period of 2 years. If we add in an electric razor, you can see it works out a little cheaper over time, but with a much bigger initial investment. With the Henson razor, however, the initial investment is much lower and the cost of shaving stays very economical. This is because the replacement blades are around 10 cents each and the razor itself has a lifetime warranty, so you shouldn't ever need to replace that razor. This isn't even taking into account the fantastic offer that Henson Shaving is giving you. Just go through the link in the description or enter the code ElderFox at checkout to claim 100 free blades with every razor purchase, which should last you around 3 to 4 years. On Salt 2057, the team orders Curiosity to attempt another drill at a site named Duluth, this time at a depth of 2 inches or 5. Drilling is a complete success. This is the first drill sample taken in over a year and the team at NASA is ecstatic. Curiosity's drill is back online and this proves that the new technique feed extended drilling can and does work. While the rover is happy with its success, the Mars Reconnaissance Orbiter is circling the planet overhead and detects a dust storm starting to grow in size. The sample is transferred successfully into the sample inlet using a slightly different technique aptly named the feed. Extended sample transfer. Due to the now permanently extended position of the drill on Sol 2074, the Mars Reconnaissance Orbiter reports that the dust storm is growing significantly in size and intensity, covering the whole planet. This series of images shows how the storm has grown. This image shows what the face of the planet now looks like. You can see huge swirls of dust almost covering the entire planet. This is Curiosity's view of the storm. The image on the left was taken just 3 stalls ago. Curiosity wants to celebrate a successful drill in its usual way by taking a selfie. So it does, even if it is a little bit dusty out there. Luckily for Curiosity, it has a nuclear power source and doesn't rely on solar panels, unlike some of NASA's previous rovers. One such rover, Opportunity, is currently exploring the other side of the planet and has been doing so for the past 14 years. Unfortunately, this is the last picture NASA received from the Opportunity rover. After 14.5 years of continuous faithful service, Opportunity stopped responding and went into hibernation. The dust covered its solar panels and the rover was unable to generate enough power to keep itself warm at night. Most of its components are thought to have been frozen and irreversibly damaged. It's unlikely the rover will ever come back online. As the storm begins to subside, the now lonely Curiosity rover takes another snap of the Duluth drill site. These 2 images show the site before and after the storm. Curiosity takes a quick picture of its drill to check for any damage from the new drilling method. All seems to be holding up well so far. In the next episode, Curiosity has some major issues with its memory, watches clouds in the sky, and sees a Martian solar eclipse. Click here to watch. Thanks for watching. Elder Fox. Remember to like, share and subscribe to keep up to date with the latest discoveries.